Ever look up at the night sky and think, what else is out there?
Yeah, like, is there something beyond what we even know how to imagine? Well, get ready because today we are diving into the mind-bending world of parallel universes.
Hmm.
We're looking at a physics paper, and it's a preprint called, get this, The Gateway to Parallel Universe and Connected Physics.
Really rolls off the tongue, doesn't it?
Right. Catchy title.
Mm.
But for folks who might not know, what does it even mean for a paper to be a preprint?
So basically, it means researchers are putting their findings out there for other scientists to see before it goes through the formal review process for a journal.
And so it's like a sneak peek.
Exactly. Gets the conversation going faster.
Love it. Okay, so this paper, it's all about some really weird stuff seen in the cosmic microwave background, or, as the cool kids call it, the CMB, that afterglow of the Big Bang. Think of it like, okay, imagine tossing a pebble in a pond. Big Bang is the splash, the ripple spreading out. That's like our universe. The CMB is those super faint traces of the ripples still hanging around after billions of years.
Nice analogy.
Right. I thought so. So scientists, they study these ripples to understand, like, what the early universe was up to.
Yeah, like trying to decipher the very first moments of existence.
Wild. So what they find in this CMB that screams, hey, parallel universes over here.
Well, they found what they call the cold spot.
Okay.
It's this region in the CMB that's way colder than it should be.
Way colder.
And I'm not talking about a couple degrees here. It's much colder than our current models can explain. It's an anomaly.
Ooh, anomaly. Like a cosmic mystery. So what are we thinking? Did somebody leave the fridge door open after the Big Bang?
Well, that's where things get interesting. This paper suggests that the cold spot could be a sign of something truly mind-blowing. A collision with a parallel universe sometime in the distant past.
Wait, hold on. A collision? Like with another universe?
Yeah.
That sounds less like a fender bender and more like I don't even know,
Yeah.
a cosmic pileup or something. Okay, but like, I'm trying to picture this whole universes colliding thing. It's not like they're giant spaceships playing bumper cars up there.
Not quite the image we're going for.
So how does it work? How do universes even collide?
Well, this paper, they're suggesting it's through something called two-dimensional time curves.
Time curves. Okay, get kind of complicated now.
Imagine, like, okay, our universe, it's not alone, right? There are others out there. And these time curves, they're like threads, sort of connecting them all.
Like a cosmic tapestry or something. Each universe is a different part of the tapestry, and the time curves are the threads weaving them together.
Yeah, that's a cool way to visualize it. And where these threads intersect or even just brush against each other, that's where a collision might happen.
So if these universes are fabrics, a collision isn't a head-on crash, more like a little snag or a pull in the fabric of space-time.
Exactly.
Wild.
And what they're saying is that cold spot, that super cold region we talked about in the CMB, that could be a lasting mark, a cosmic bruise almost from one of these collisions way back when.
Cosmic bruise. Man, I love that. Okay, so we've got collisions creating ripples in space-time. Does this tie into, like, people who talk about glitches in the Matrix and stuff? This paper mentioned the Mandela effect, where folks misremember things.
Sure.
Could that be connected to these cosmic fender benders?
So that's one of the more out there ideas in the paper.
Okay, fair enough.
They suggest those glitches, right? They might be like mini versions of these interacting time curves. The cold spot, maybe that's a huge example, but smaller inconsistencies like those memory things, maybe those are connected to these teeny tiny interactions between universes.
Whoa. Before my brain totally melts, let's reel it back into the more science-y stuff. The paper also mentioned something called eternal inflation, right? What is that all about?
Right. So eternal inflation, it's this wild idea that our universe, it might be just one of many that are constantly being born.
So it's like the universe is having babies, universe babies.
Kind of. It's like a bubble bath that just keeps expanding, new bubbles popping up all the time, and each bubble, that's a universe.
So not just a multiverse. We've got a multiverse that's like a never-ending fireworks show of universes.
Pretty much.
Okay, so my brain is full. If our universe is already taking up space, where are all these other universes coming from? Like, where do they even fit?
That's where codimensions come into play.
Codimensions. Hit me with it.
Okay, so picture this. Our universe, it's like a train track, right?
Okay, I'm with you.
Now imagine there are infinite parallel tracks running alongside ours, but like in a whole different dimension. We can't see them, can't touch them, but they're there. These other tracks, those are other universes. The space between them, those are codimensions.
So codimensions, that's the cosmic scaffolding holding up the multiverse.
Exactly. And the paper, it uses some pretty intense math to explain how these codimensions could let universes branch off from each other during this eternal inflation thing.
Okay, so lots to unpack here. We've got the cold spot,
Yeah.
maybe caused by a cosmic fender bender with another universe.
Mm-hmm.
We've got eternal inflation, which is like a never-ending baby boom of universes.
Mm-hmm.
And then we've got codimensions, which are like the secret passages that let all these universes exist without bumping into each other.
You got it.
My head is spinning.
It's a lot.
It really is. So is this paper saying, hey, we've got proof, parallel universes are real, case closed?
Not quite. Gotta remember, this is just one paper, one idea.
So the jury's still out on whether or not we're living in a multiverse.
Exactly. But, even if these findings get challenged later on, it still makes you think, right? Like, what if what we see out there, what we can study, what if that's just a tiny, tiny piece of what's really out there?
Man, makes you realize just how much we don't know. Makes our universe, or should I say multiverse,
Hmm.
even more awesome to think about. I mean, seriously, this cold spot, this thing in the CMB, if it really is like a bruise from bumping into another universe.
That changes everything we thought we knew about the Big Bang, right? About how it all started.
Totally.
Yeah.
It would mean our universe, the one we know, the one we can study, it's not all there is.
Right.
It's like just one of who knows how many universes out there, each one maybe with its own set of rules, its own history, its own everything.
So you're saying, like, the Big Bang might not have been this one-time thing. Maybe it's happening all the time, all over the place with these codimensions we were talking about. That's where it all goes down.
Could be. It's still a theory, but it's pretty wild to consider, right?
Weil doesn't even cover it. So, okay, let's say these other universes exist. What are they like? Are they similar to ours? Or are we talking like totally alien, can't even imagine it, kind of different?
That's the million-dollar question, isn't it? And it's one that scientists and philosophers have been debating for ages.
Yeah.
This paper, it doesn't give us all the answers, but it definitely gets you thinking, right? Like maybe the laws of physics, gravity, even time itself, maybe those work differently in these other universes.
Whoa. See, now you're just messing with me. I can barely understand gravity in this universe. But, okay, let's say, just for fun, that all of this is true. We've got a multiverse, it's full of universes that are totally different from ours. What then? What's the takeaway?
Well, I think the biggest takeaway is that we're still just scratching the surface of what's out there. Our universe, or should I say multiverse, is far stranger, far more complex, and far more awe-inspiring than we ever imagined.
I love that. And you know what? It makes you want to grab a telescope and just stare up at the sky, hoping to catch a glimpse of another universe.
Well, we haven't quite figured out interdimensional travel just yet,
Darn.
but the fact that scientists are even asking these questions, the fact that they're exploring these possibilities, that's pretty amazing.
It really is. Every time we think we're getting close to understanding the universe, we uncover a whole new layer of mystery. And I, for one, wouldn't have it any other way.
Me neither.
Well, that brings us to the end of our deep dive into the world of parallel universes. It's been a mind-bending journey,
It has.
and we hope you've enjoyed it as much as we have. A huge thanks to our expert for, guiding us through these complex concepts. And to our listeners, thank you for joining us. Keep looking up at the stars, keep asking those big questions, and we'll see you next time on The Deep Dive.